Why did I subtract by 9?
Oh, because that's last thing he did.
The last thing? That's not a mathematical term. The last what?
You know what I mean?
Operation.
Thank you, the last operation. Okay, so it's the last operation being applied, so it's the first one I undid. When I got down to 4x equals 0, what did I do then? Divided by?
Almost missed the chance.
4, thank you. Kelsey, right now is not the time to clean out your backpack.
I'm not.
Right now is the time to learn math.
Okay, yes, sir.
The math that you did not get right on the homework last
Okay,
night.
yes, sir. Yes, sir.
Okay.
Sorry.
We are not bad mathematicians, we're bad students. That's the only thing we gotta fix. Once we fix being good, bad students, a lot of us are gonna be way better. And the reason I bring that up is, and I'm not trying to beat y'all down, I need you to understand, so many of you think, man, Mr. Kinney, I'm not good at math. False. You can be fantastic at math. Your study habits, your work in class is preventing you from being excellent at mathematics. Do the homework so that you can ask questions the next day. When you're in class, you're not distracted by other crap. There's a reason why the cell phones go up. It's because students kept being distracted by their cell phones. When you're in class, be in class, focus on your learning, and grow.
And because, he ran his mouth.
I've been thinking about doing it for a long time, and because students kept getting distracted by their cell phones, and I was over it.
But you said.
How?
Yes, he was the final straw that broke the camel's back. Continue.
On number 2, how do you go from 8 minus 4y plus 3y to 8 minus y?
What's negative 4y plus 3y?
Oh, I didn't think it was.
Wait, hold on. Let me see.
That's an important thing to notice, is that is effectively, don't forget, when we subtract, that's the same thing as adding a negative. So that is negative 4y plus 3y. And that is a great question. See, those are the questions that should be driving things. Those are important and necessary questions so we all understand. Corell, you didn't even do this. Have you written this crap down?
I just about to start writing it down.
No. This went up 5 minutes ago. 5 minutes is not when you start writing it down.
Yes, sir.
This is what I'm talking about. You can be great at mathematics, but you keep preventing yourself by not doing what you need to do.
Yes, sir.
Actually, I lied. This has been up for 10 minutes.
My biggest problem is I just forgot how to do the properties of equality last time.
But at least so write that note to yourself, right? That's a thing where you're like, man, this is what I missed. This is what I was forgetting. Make a note to yourself. Man, Peyton, I was being silly. I'm not to you, but you write that to yourself, right? Hey, I was being silly. I forgot my properties of equality.
And then I also had a big problem with 17 and 21.
We'll look at those in a
On
second.
the line, that's not, or not 21, just 17.
Okay,
On
but
the line,
look right here at number 2. One thing I want to emphasize, and I want to make sure you're all clear on, is this. X is equal to 4 minus 2y. So what can I do with that 4 minus 2y? If x is equal to 4 minus 2y, what can I do with that 4 minus 2y?
Plug it in!
What's the better math term? That's good, but what's the
Substitute.
substitute? Hey, what did they do in soccer when one person comes off the field and another person takes that person's place? What's it called?
Substitution.
Oh, there we go. Yeah, substitution. Okay. X is literally equal to 4 minus 2y. So 4 minus 2y is going to get substituted in for x. Notice it goes into the other equation. We all good with that concept. Now what I want you to notice out of that is right here. When you substitute that 4 minus 2y in for x, how many variables are you left with?
You good?
One variable.
What's in that cup, Kelsey?
Hey, focus on your math learning.
Sorry.
We're left with one variable. Can I solve an equation with one variable for exactly what that variable is equal to?
Yeah.
Y equals negative 1, right? So when I substitute this in for x, I'm left with one variable. I can solve that equation and know exactly what y is equal to. Once I know what y is equal to, am I done?
I don't know.
No, because I don't want to know just y. I also want to know, got to plug that in to get what x is equal to, because this point is the solution, or these values are the solution as a point. how could I use Desmos to check myself on this system of equations?
Plug it in the graph.
So I could graph it on Desmos, right? If I were to graph this system of equations in Desmos, what would I be looking for?
Intersection.
The point of intersection. That point is the point that makes both equations true at the same time.
Yep.
All right. Hopefully that's a good recap. Peyton, what was your question?
17. Alright, the line had me screwed up.
Why?
I don't know why.
Did you get x is greater than 7?
No, because the properties of
You're messing up on the properties of equality.
Yeah,
And I will point this out, I combined certain steps here, you should probably do them separately, but you can do this. Adding
Yeah.
6, so I subtracted 6.
I just kind of I look like a second grader looking at Hillcrest's mouth. I was like,
We're supposed to do 21 and not 20. Wait.
I could not figure out how to do it.
But, I mean, like, and you can do it as 2 separate steps, but notice I created 0 here, 0 here, so 2x plus 5x.
7x.
Thank you, 7x is greater than 55 minus 6.
Oh, 49.
49, thank you.
I didn't realize that was a question.
Just a question to all of you. Now what can I do to finish solving this inequality?
Well,
By 7.
She said.
X is greater than 7. But Peyton, all you then do is you go to the graph. If you're going to graph it, you have the number 7.
okay, to be fair, I did not remember how to do it, so.
I mean, I know, but like you said, you had the graph all messed you up. I mean, once you solve it, you're good. And again, what resource do y'all have, ladies and gentlemen, to solve an inequality if you get stuck?
The symbol.
Simbo Lab. Start using your resources. Yes, Kelsey.
Are we supposed to do 20 or 21?
Which one is right there?
We didn't show you both circle 20s.
Yeah, I thought it was-
That's 21.
Hey, somebody
Either way,
left
I
this in
didn't
here.
know.
I don't know either.
Say again?
Somebody left this in here, I don't know whose it is.
I put it on your desk at the beginning of class because we're using it today.
I didn't.
So, Notice we have the 7. Y is an open point.
Because you can't equal it, or
Is-
you can't equal
It's not just that you can't equal it. Plug a 7 in. Is 7 greater than 7?
They're
it.
equal.
So is 7 greater than 7?
No,
No.
So is 7 a solution?
no.
No. So it's more about the idea that it's not a solution, Peyton, and it's not a solution because it's not equal to, right? If it was equal to, it could be a solution. So it's an open point, it's not a solution, why am I shading to the right?
Because it's gotta be greater than.
Kinda.
X has gotta be greater than 7.
True.
So what's greater than 7? 6? No? Okay.
See,
8
that's what you
is-
want to focus on. So like if I were to pick on this point right here, what is that?
I don't know, I can see that.
7, 8.
None.
True.
Wait, so if it's true, that means it's a...
Solution.
And I'm shading in the direction of the...
Solution.
Has that changed?
Nope.
No, guys.
Well, it's
Girls?
purple.
Huh?
It's purple, yesterday it was green, so a little bit.
Okay. So please note, and make these notes to yourself, solve. Right? If you got stuck, like you're just solving, use those inverses, use those properties of equality. We graphed it, we explain why we're graphing, we take notes on that, Corell, instead of playing with our jackets.
Didn't take notes. You said solve, and I wrote solve.
You were playing with your jacket.
I already wrote it down though, Miss King.
Okay? Did you write notes about this
Where's my pencil?
as we were talking through it?
No, cool.
No, sir.
See, these are the things we gotta learn how to do.
I got the one right though.
Okay.
You said we take notes on though?
I mean, you gotta fully explain these things,
Yes,
so
sir.
it'd be a good idea. So, where did this interval notation come from, though?
I mean, that's something we learned
The
out
instruction said so. Wait, what?
Thank you. Yes, the instructions did tell us to use interval notation. How did I get this interval notation?
Okay, so what is interval notation? It's saying that it's basically explaining what it is, right? So x, when x is the element of real numbers.
That's set notation. We're looking at this interval notation.
Oh, wrong thing. Okay.
The
Well,
7,
that's the set of solutions. But
kind of, it's intervals, not sets, though. The 7 is the what for my solutions?
You said what?
The 7 is my what for the solutions?
Starting point. Uh-huh. It is. It's your slope. Yeah. Your slope. your miles,
Minimum.
minutes,
You good?
miniature,
Minimum.
minimum.
Isn't that the minimum value?
Oh, yes,
What's the infinity?
it's the max. Even though you can't, that didn't identify it.
But we need some way to indicate that it keeps going forever and ever, and that's infinity. And we put a comma in between.
Facts. Facts.
So we write down that note of minimum and maximum. Why is it parentheses?
Because it's a point, and it's a point.
What do you
So,
think is the most
not a point.
important amount that we use?
Yeah.
It is not. Hey, tell me, how are you going to get to the point 7 comma infinity?
Infinity is
It's
not.
a point with a line.
Hey, Kelsey,
infinity
this
not
is
a
called the
number.
what?
Yeah.
Interval notation, right?
Yeah.
Yeah. Is interval notation a point?
No.
No, it's a set. of
No, it's
solutions.
a notation.
It's a notation. It's a notation for this interval of solutions. And it's parentheses because the values can't be equaled.
By the way, infinity is not a number.
Who asked?
Okay. So we need to be aware of interval notation because you will have homework on this over the weekend.
What? You're so mean. Oh my gosh. Can't have a weekend. Oh my gosh.
Oh.
Just because of Kelsey, we're doubling the homework.
Wow, Kelsey,
Oh,
thanks
just
so
weird.
much.
Oh my gosh. I was just kidding. Here, take my joke.
Complain again? I might actually double the homework.
Oh.
Okay,
Kelsey.
Because I need you to understand the 6 problems that I am assigning tonight for homework is less than half of what I had every single night when I was in high school. So I'm not asking you to do a ridiculous amount. You want to be lazy and I'm not letting you be lazy. It's because you won't learn as well.
Well, what about Sunday?
I know it is. Really quick note, why did this greater than become a less than?
You had to flip the signs because it's a negative.
A little bit more detail.
Divided by a
Well.
negative.
There we go. It wasn't just because there's a negative, it's because we were doing what with that negative? Dividing, anytime you multiply or divide both sides of the inequality by a negative, you have to reverse the direction, not just flip,
Okay.
reverse that direction.
Reverse the
Reverse,
direction of
whatever.
the sign.
Same
We need to learn proper mathematical terminology.
Flip it your.
And then we needed set notation here. Man, I'm struggling with drawing my curly brackets. There we go. So notice we just start with the curly bracket, and then what comes immediately after the curly bracket?
X.
So the variable. That's literally all it is. You can use other variables, it's just the variable. What always comes after the variable?
When.
That when bar, right? WHEN is the set of x when something is true. We'll go into more detail about this at a later point. You're pretty much always going to do the set of x when x is an element of the real numbers. Dealing with every decimal that's out there. However, it's not from negative infinity to infinity. Notice it's always just the inequality.
Yep.
Actually, there was one point where you were showing us that it'd be x when x is less than or greater to something.
I have no clue what you're referring to, but probably.
It was.
Not saying it's always this, just saying that that's what we're usually looking at. Alright, we gotta get going, y'all.
It was like x when x is less than or greater to 7, and then less than or greater to whatever. I don't know those.
So hopefully you took some good notes so that you can be successful. Julia, we're gonna take care of you because I know that is a rough time having a cast on.
Yeah, that.
And I apologize.
That homework was a pain in the butt.
Just to clarify for anybody watching, it's not like I put a cast on Julia, she just had issues and I feel bad for her. I don't know what happened fully, she was trying to explain to me. I just don't want that to be on the internet. Oh, Mr. Guinea like broke some girl's arm. No, that's not what happened.
Yes, it is.
Behind closed doors.
Wait,
Alright.
Did you not just hit her earlier
But-
on?
Let's look at the objectives for today and then we're gonna do the dream job salary task, which you already have on your desk. Peyton, for yawning or huffing, whatever that was, can you read our first objective for us?
So I yawned and
That's
okay,
your
fine.
punishment.
I can identify linear versus exponential functions.
Okay, I need everyone to write this down because we're about to cover some critical ideas. This should go on the dream salary task. When we talk about a linear function, what do we mean?
An additive rate of change, a
Yep.
common difference, whatever. What do you look
We
for?
cannot forget, it doesn't matter whether it's a table, whether it's a graph, whether it's an equation, we're talking about an additive rate of change. What do we call that additive rate of change though? It
Slope.
could be a common difference, but typically we're calling it a what now, Shelby? Slope.
Okay, you got mad because I used to say it was an additive rate of change. And then
What?
you changed it to, you changed it to slope, okay?
I didn't change it to slope. When it's a sequence, an arithmetic sequence, it is called a common difference. When it is a linear function, it is called a slope.
I'm more pretend I remember that.
Okay. So do not forget, because this will impact things moving forward today. If it's a linear function, it has an additive rate of change. It has a slope. And we've got to remember, if we are repeatedly adding, what operation shows that? Right? Multiplication will show the repeated addition.
And then you can divide as well, right?
Okay?
Really?
Really you just add a negative being multiplied. So, what about an exponential function? Has a multiplicative rate of change. And this is fundamental. What operation is going to show that multiplicative rate of change? An exponent. We haven't talked about these ideas in a little bit, so I wanted to reestablish this before we get started. I miss having Desiree be able to read these objectives. Hopefully she'll read one soon. Jalea, can you read our second objective for us?
I can use
Mathematical.
reasoning to justify the selection of one relation over another.
Okay, we're going to look at two different situations, and you can't just say, hey, this is what I want, because sometimes there's things you're just not aware of. We need to use mathematical reasoning to justify the selection of one relation over another. What mathematical representations do we have available to us to help us with our mathematical reasoning? Tables, graphs, pictures, the algebraic. What do we mean by algebraic though?
Not sure.
Yeah.
Correll, what do we mean by algebraic?
I don't know myself.
Peyton? It's a good thing we're covering this then.
Algebraic would be tabular, graphical, pictorial.
Actually, those are the other representations.
What are you,
What do we mean by algebraic?
Oh, I didn't.
Like numbers.
functions.
Function.
The what of functions? The starts with an E.
Exponent.
Explanation.
The verbal. How about the equations, the expressions, the inequalities?
Alright.
Right? We're using tables, we're using graphs to help us with things, but this class is called what?
Those are big words.
Algebra 1B. Your face. But Algebra 1B. So we're looking at using those things to help us with the equations.